Hello and welcome back to this episode of Cosmic Kingdom. Today I have a brave person that is going to subject himself to the cosmic box. His name is James Pett and he works with me here in the University of Surrey. Hello James.
Hello.
So James, tell us a little bit about yourself.
So I'm a PhD student here at the University of Surrey. I work on star clusters, especially near galactic centres of both our own galaxy and dwarf galaxies.
What is a star cluster?
So a star cluster is it's a big sphere of stars, which the stars are all usually born at the same time. You study star formation and star clusters as well. So I usually study their evolution past the initial phase. So you assume you assume how they're formed in some distribution, and you can evolve them with time.
So, and why these stellar clusters are so important?
So they tell us a lot about star formation because these stellar populations are very old. So we can see how, first of all, stars evolve in terms of dynamically, and also the stars themselves, how they evolve due to stellar evolution processes like burning hydrogen and then helium and so on.
So, how many stars does a cluster
So
have?
it depends on the type of cluster. So you get some big objects called open clusters, which usually have 10,000 or so stars. But some of the very old objects, like globular clusters, they're very, very big, ancient objects, and they can have a million or so stars.
So when you say ancient, how old are those stars?
So some of the oldest ones can be like 10 billion years old.
Wow, but that is almost as old as the universe.
Yeah, so these are why they're very interesting objects, because they can tell us a lot about the early formation of galaxies and stars
That's
at
so
the beginning.
Are you ready to enter the cosmic box?
I am indeed.
Okay, so
Let's
let's go. James, are you really sure that you want to enter the cosmic box?
Of course, let's do it. So a disk galaxy is a galaxy which has a big disk of stars with a bulge in the centre and maybe a black hole, and then a big halo of dark matter, we think. In the disk galaxy in which we live in, the Milky Way, the very centre looks like this. So we have, at the very centre we have a nuclear star cluster, which is, we think at the very centre there seems to be signature that there's a supermassive black hole. So this is a black hole of about 4 million solar masses. So a very massive object, and very, very, very dense. Surrounded by a cluster of stars here. And further out you can see there are two other star clusters nearby, called the Arches cluster and the Quintuplet cluster. So these are very young, massive star clusters. At the very centre of our galaxy, inside the nuclear star cluster, most of the stars are very old, but there's a small disk of stars which are very centrally concentrated, very near the centre, and they're about less than 10 million years old, which is actually very young on cosmological timescales. So the reason that this is very interesting is near to the black hole, when you usually have normal star formation, such as what Moncho usually studies, these giant balls of gas, these molecular clouds, would be torn apart completely by the tidal forces of the supermassive black hole. So it was long thought that maybe star formation can't happen here. So people looked for different different scenarios to see if you could bring the stars to the galactic centre. So motivated by the fact there are two other star clusters outside, people thought that maybe these star clusters could fall into the galactic centre within the lifetime of these massive stars, these young stars. So what we did is we ran simulations of star clusters evolving near the supermassive black hole to reproduce the observations of this small disk of young stars in the centre. So here you can see one of our typical simulations where you see a star cluster orbiting the very centre of our Milky Way, near the supermassive black hole. And as you can see, when star cluster approaches very close, you get this large shock caused by the gravitational field of the black hole, which causes lots of stars to escape. And this happens very early on, so very far out, so that you lose lots of stars in this large region rather than the star cluster falling all the way to the centre as seen in observations. So this shows us that this model doesn't work, and the star formation probably happens in the centre itself. Basically what we found is that you always end up with a large distribution of young stars which would be observed much further out. So 10 parsecs instead of less than 1, which is what the disk is projected in. So this is actually very interesting, because although it seemed like the model failed, it basically shows us that you can't bring the stars out from elsewhere. So in order for them to be where they are today, they must have formed there, which is very challenging for current star formation theories. But some people think it may be possible if you happen to have a gas cloud that falls straight onto the galactic center, and you get a massive shock as you pass the black hole. So you get loads of compression, which could maybe form stars. But so this is one example of why studying star clusters or globular clusters is very interesting, because it gives us information. It can give the evolution of galaxies on large scales, or in scales like this, it can tell us about star formation locally in the current universe. And I think that's why it's a very important field of astrophysics, and that's why it's so interesting.